Hello everyone, I am Soham Parmar, student of B.Tech Engineering Physics IITR. Today I am going to give a brief presentation on the tachometers. Let's first go through the overview of the presentation. First of all, we'll go through the introduction part. Then we will go through mechanical tachometers, which comprises of handheld tachometers and centrifugal tachometers. Then we will see the electrical tachometers, and finally we will go through the photoelectric tachometers. Now let's go through the introduction. First of all, speed is defined as rate of change of motion. Linear speed is expressed in the units of meter per second or kilometer per hour, and angular speed is expressed in the units of revolutions per minute or radian per second. The continuous measurement of linear speed is usually made in terms of angular speed and then converted into linear speed of a reciprocating part. The RPM measurement is generally very important when controlling or monitoring the speed of motors, conveyors, turbines, etc. Angular measurements are made with a device called tachometer. The word tachometer is derived from the Greek words tachos, meaning speed, and metron, meaning to measure. Tachometer is broadly classified into three categories, namely mechanical tachometer, electrical tachometer, and photoelectric tachometer. Now let's first go through the mechanical tachometers. It consists of the mechanical parts and mechanical movements which are used for measurement of speed. The most commonly used mechanical tachometers are handheld tachometers and revolution counters, which are also known as centrifugal tachometers. A handheld tachometer is basically a portable instrument. It consists of a spindle, a starting and a reset button, a dial, a stopwatch. Now suppose we have to measure the speed of the shaft or any other rotating part. First press the reset button so that all the parts of the tachometer gets reset. Then attach the spindle of the device manually to the shaft or rotating part to measure its speed. Now as we touch the spindle to the rotating part, the spindle begins to move with the same speed as that of the rotating part. Then press the starting button, the stopwatch gets started. Then the total revolutions per minute can be easily calculated. We can also calculate the total revolutions per second. So the number of revolutions can be calculated using the dial and the time can be calculated using the stopwatch. Now let's see centrifugal tachometer. It can measure speed up to 40,000 RPM. The main part of this tachometer are a central spindle which is surrounded by a spring which is a compression spring. One end of the spring is connected to the top of the tachometer and the other is connected to the sleeve. The sleeve can move up and down easily on the spindle. The sleeve is attached to a sector and pinion arrangement. Both sector and pinion have a teeth on its surface. Pinion is connected to a shaft which is a pointer which is attached to a scale. So the two fly balls of equal weights are also connected on both sides of the spindle. Now let us see its working. The spindle of the tachometer is attached to the input shaft and so that we get the same movement of the spindle, and because of the rotational movements the fly balls move and the centrifugal force is experienced by them outwards, and therefore the sleeve moves in the upward direction, and therefore the sector moves and so the pinion moves as well, and so that the pointer moves over the scale giving corresponding reading. This scale is designed to give readings in terms of RPM. These tachometers have a distinct advantage over the revolution counter in that they indicate whether or not the speed remains substantially constant. The accuracy of this apparatus is plus minus 1%, and the limitation is that we are required to change the spring over time because it loses its property. Now let's go through the electrical tachometers. The electrical tachometers provides the advantages of electrical transducers and therefore are preferred over the mechanical tachometers. The electrical tachometers depends upon an electrical signal which is generated in proportion to the rotational speed of the shaft. The various designs of electrical tachometers are Number one is the commutated capacitor tachometer, which is based on alternately charging and discharging the capacitor that is controlled by the speed of rotating member. And the number two is the eddy current type tachometer. Now let us go through the photoelectric tachometers. In a photoelectric tachometer, the measurement of speed is done using the light energy which is being converted into electrical energy. There are basically two methods to perform this. Let's see method number one. When looking into the construction, there is basically a lamp which is acting as a light source. There are two lenses, a shaft which is connected to reflecting surface, and a photoelectric cell. Now let us see the working of this method. The light from the lamp source over here gets focused on the surface which is attached to the shaft, which is 50% black and 50% white. So when it falls on the white surface, it gets reflected and then is focused upon the photoelectric cell through other lens. When it falls on the black surface, there is no such phenomenon taking place. And the photoelectric cell gives the electrical output which is proportional to the number of light pulses which are generated. Now let us go through the method 2. First of all, let's look through its construction. It basically consists of a shaft which is connected to a motor which is acting as a speed source. On the other hand, the shaft is connected to a disc with equidistance holes. There is a light source, there is a light sensor which is connected to an electronic counter which is connected to a display device. Now let us go through its working. When the motor is switched on, the rotating disc which is attached to the shaft starts rotating with the same speed. When the light beam is passing through the holes, it is being detected by the light sensor and calculated using the electronic counter. When the light beam is falling on the metal part, there is no such phenomenon taking place. The frequency of the pulses over here is directly proportional to the shaft speed, and so will be the frequency of the electrical output pulses from the photoelectric cell. So these were various methods to measure speed using tachometer. Thank you.